Determining domain and range graphically. Here we have a parabola. It goes off in this direction forever, and it goes off in this direction forever. It has a vertex at 2, -3. Since the graph goes off forever vertically, and since I can pick any x value and get a corresponding y value, so I can pick an x value way off to the left, I can pick an x value way off to the right, there are no restrictions on the domain of this function. So the x's can live anywhere in this function and I will still get a valid y value. So in that case, I'm going to write that my domain is x is an element of the real numbers, and it's real because this is a continuous line, it's not individual dots, such that, or it's just, actually there's no restrictions, it's just x is an element of the reals. My range, again, this function has any value for y. However, it can't go below -3 on the y-axis. So the restriction on my y values is that they can't be anything less than -3. My range will be y is an element of the reals such that y is greater than or equal to -3. So it can be -2, -1, 1, 2, 3. It just can't be -4. It can't be anything below this -3. Here we have a parabola that's on its side. Again, the parabola goes off all the way to the right forever, and it can go up as high on the graph forever. I can keep on going forever in height. I can keep on going forever downwards along the y-axis. However, I cannot go any farther to the right on this graph, or to the left on this graph, than the -1. So my restriction is that my x values can't be anything less than -1, less than or equal to -1. So I will write my domain is x is an element of the reals such that x is greater than or equal to -1. As I said before, there is no restriction on how high or low in terms of y values that this function can go. This can keep going up higher, this can keep going down lower. So there are no restrictions on the range of this function, or of this relation. So I will say range is y is an element of the reals. Here we have a function that goes in a long swoop this way and in a long swoop this way. This line here, this section here, seems to get very close to the horizontal line y equals 4, but it never touches it. It also seems to get very close to the vertical line x equals 1, but never touches it. These two lines here are called asymptotes. They are lines that a function or relation approaches but never touches. So, since I can't touch x equals 1, that's going to be the only restriction on my domain. The function goes off to the right forever, it goes off to the left forever. So there are no restrictions on the domain other than it can't be equal, the x values can't be equal to 1. My domain will be x is an element of the reals such that x is not equal to 1. So I'm saying in this function x can be anything other than 1. The x values for the parts of the line can be anything other than 1. If we go back to the graph here, if we talk about horizontally approaching the y equals 4 asymptote, the function can get very close to it but not touch y equals 4. It can get very close to but not touch y equals 4. So the only restriction on the range is that the y value for any coordinate point along this graph cannot be equal to 4. My range, y an element of the reals, such that y is not equal to 4. Here I have a circle. It has a radius of 3. It goes as far as -3 on the left side on the x's and +3 on the right side on the x-axis. It goes as high as +3 on the y-axis, and it goes as low as -3 on the y-axis. So the relationship exists anywhere between these boundaries on the circle. My domain will be x is an element of R such that x is greater than or equal to -3, less than or equal to 3. So that says that this relationship in terms of domain lives between -3 and 3 on the x-axis. All the x values for any point on this relationship will have a value between -3 and 3. The same in this case is true for the y values. Any y coordinate of any point on this curve will have a y value between -3 and 3. So my range, y is an element of the reals such that y is greater than or equal to -3 and less than or equal to 3. Now I have a situation where I don't have a continuous line anywhere. I have distinct dots. Since I don't have a continuous line, I cannot refer to the domain and range of this expression being in the real numbers, because you can't have decimals. So there's no line that joins them, so they are distinct. So I either have to use the natural numbers, which go from 1 and get more positive in terms of 1, 2, 3 in whole numbers. I can use the whole numbers, which start at 0 and only get positive, 0, 1, 2, 3, 4, etc. Or I can use the integers, which are whole numbers, but they can be negative and positive. So now I'm just going to look at what are the smallest x values, biggest x values, smallest y value, biggest y value. My domain will be x is an element of the integers such that, now my smallest x value is -2, my biggest x value is 2. So x will be greater than or equal to -2, less than or equal to 2. My range, smallest y value I have is -2. The biggest y value I have is 3 for these two guys up here. My range will be y is an element of the integers such that y greater than or equal to -2, less than or equal to 3. Now let's look at this situation where we have a line. It's a continuous line, but at one end it has an open dot. This open symbol means it's not exactly equal to that coordinate. So in this case, it's not exact. You can't exactly get a -4. You can get very close. You can get -3.9998, 3.9999, but you can't get exactly 4. And in terms of y, I can get very close to -2 for a y value, but I cannot get exactly to 2. So my domain goes from -4 to 5. It's a real number because it's a continuous line. Now, since I've got this open hole here, I cannot use greater than or equal to. I can only use greater than. It can get very close to -4, but it cannot be equal to 4. And then this end, since it's a closed dot, that can be less than or equal to 5. Similarly, my range. The smallest value on the y-axis that I have is very close to -2, but it's not exactly equal to -2 because it's an open hole. So I'm going to say y is greater than -2 and less than or equal to 3. Last example. I have a situation where I've got two parabolas on their sides. They can exist anywhere out here. They can exist anywhere out here, but in this area between -3 and +4 on the x-axis, there's no relationship. That doesn't exist. So this is an area where the relationship does not live. In terms of my range, just like the other parabola on the side, this can endlessly go up, this can endlessly go down, this can endlessly go up, this can endlessly go down. So in terms of y's, there is no restrictions. But in terms of x, this relationship lives everywhere to the left of -3 and includes 3. So I'm going to say my range, or my domain, so in this case I'm going to say x is less than or equal to -3. It can be anything out here. So x is less than or equal to -3, and it's greater than or equal to 4. So reading from the inside out, x is less than or equal to 3, and x is greater than or equal to 4. For my range, there is no restriction. And that is how you determine the domain and range of a relationship from a graph. Thank you for viewing this video.